Hello students, today we are going to learn about angular momentum and relation, okay, and also conservation of angular momentum. Okay, this is what we are going to learn. First of all, conservation of angular momentum, dl by dt if you proved is equal to 0 means that's going to be conserved. Okay, so L is called angular momentum. Okay, first we are going to learn angular momentum. Angular momentum is equal to linear momentum into radius. The next one is SI unit of angular momentum, dimensional formula for angular momentum. Torque is equal to I alpha. This is one of the relation we are going to relate with angular momentum also. Torque is equal to I alpha we are going to learn. Angular momentum is equal to I omega we are going to learn. Rate of change of angular momentum is equal to torque we are going to learn. Okay. And finally, the conservation of angular momentum dl by dt is equal to 0. When we are getting like this, L is going to be a constant, conserved. Okay, this is what we are going to prove. The first thing. Angular momentum is equal to linear momentum times of radius. What is linear momentum? Mass into velocity. So mvr. Okay, mass unit kg, velocity unit is a meter per second, radius unit is a meter. Okay, so kg meter per second into meter. Okay, so meter we can write meter square, kg meter square second minus 1. From denominator to numerator, if you are taken as a second as a numerator, second inverse will get. Okay, so finally kg meter square second minus 1. Now what about the dimensional formula? Mass is m, length is L, time is t. So length is square, time is minus 1. Okay, dimensional formula also, angular momentum we got. Okay, the next thing, small relation between linear motion and rotation motion because it's required. Okay, in a circular motion, if you want angular length, angular displacement, so it is angular displacement is equal to arc length by radius. Okay, imagine for full circle, arc length is circumference of circle 2 pi r. Radius is r get cancelled 2 pi 360 degree. So this equation is correct. Theta is equal to s by r. S is arc length, theta is angular displacement, r is radius. S is equal to theta times of r. If you are differentiating this equation, rate of change of displacement, velocity, rate of change of angular displacement, angular velocity into radius. Okay, so v is equal to omega r. Again I am differentiating. Okay, velocity by time, angular velocity by time. This is going to be linear acceleration, this is going to be angular acceleration. A is equal to alpha r. Okay, this relation we are going to use inside the formula. Okay, torque is equal to in turning effect, torque is equal to force into perpendicular distance. Force is mass into acceleration. Acceleration is equal to alpha times of r. A is equal to alpha r. Now only we found this relation. Okay, if I substituted this one, so I will get m alpha r mr square alpha. Okay, what is inertia? Inertia is equal to mass into radius square. Okay, so torque is equal to I alpha finally we got. Okay, the next thing, angular momentum, linear momentum times of radius, linear momentum mass into velocity. Velocity I know it's omega times of r. If I substituted omega times of r, mr square omega, I will get mr square, we can take it as inertia. Angular momentum is equal to di by dt. Okay, then finally dl, L is equal to I omega. If you are differentiating this, dl by dt is equal to I d omega by dt. What is d omega by dt? Angular velocity by time period, which is called angular acceleration, I alpha. Torque is equal to I alpha. So dl by dt is equal to torque. When the external torque is 0, our dl by dt is become as a 0. So differentiation of 0 is going to be a constant or conserved. Okay, whenever you got dl by dt is equal to 0, when the dl by dt will become 0, when the torque is 0, dl by dt is become as a 0. So that is the time L is become as a constant. Okay, thank you.